Once upon a time, in a land far away, there was a happy little village on top of a hill. There lived a very special hero with a very special Spotify playlist. Everyone in the village loved to listen to his playlist while out and about. The songs in it made the people dance and sing and laugh. "We love your taste in music," said the people. "Why don't you open up your playlist so we can add songs to it and make it better?" "What a great idea," thought our hero. And with the snap of his fingers, the Spotify playlist became collaborative. Now everyone was free to add or remove any song at a whim. Little did our hero know what horrors would soon come from within. The playlist was flooded with tunes from all around, but mostly crappy ones were to be found. Everyone's vibe got ruined. The once happy and careless village was now bitter and filled with dismay. Our hero had to do something about this. Oh, but what? Spotify didn't have a way for the villagers to decide which songs make it in and which don't. "I know," said our hero with delight. "I'll ask the codesmith. He'll know what to do." So he ran down to the codesmith, explained him the whole story, and asked for his help. The codesmith was also a fan of the playlist, so he didn't need much convincing. "No need to waste any time then. I'll code something up in a jiffy." And with that, our codesmith got down to work in his lair in his quest to rid the village of its despair. So let's recap. We have a collaborative Spotify playlist with many users and no control over what goes into it. A valid solution to our problem would be one that, number one, allows free access to anyone that wants to listen to the playlist, and number two, only allows the addition of songs that have been approved by the playlist listeners. With that in mind, we can create a new public non-collaborative playlist that anyone can listen to. This solves most of our problems except for the song voting. And for that, we could build our own voting mobile app, spend days trying to code up all of its functionality, handle song addition notifications, go through the tedious App Store submission process, distribute it to all of our friends, hire a team of lawyers to sue Apple once they remove it from the App Store. Or we could also leverage an existing widespread messaging app, make a group chat, add all the people we like in it, and make a bot that the users will interact with in order to add the songs up for voting. Yeah, that sounds a bit better. So it's settled. We will use Facebook Messenger. Literally everyone has Messenger installed on their phone, and with its feature-rich API, it's the perfect match for our... Wait, what? Messenger doesn't support adding bots to group chats unless you pay up for and use Facebook for Workplace? So it's settled. We will use Discord. With its simple-to-use, feature-rich, and well-documented API, it's the perfect match for our project. Now, if anyone wants to add a song, they post it to the Discord channel. Our bot initiates a vote. The guild members cast their votes. And if the vote fails, nothing happens. But if it passes, the bot uses the Spotify API and adds the song to the playlist. Pretty simple. And great! Now that we've cleared up most of the groundwork, we can get cracking. First off, we make a playlist and make sure that it's public and non-collaborative. Then, we head over to the Spotify Web API reference page to see which endpoint we can use to add songs to our playlist. And bingo! We can see that this endpoint has several parameters, but for our project, we're only going to need the first four. Setting our URI, playlist ID, and content type parameters is easy enough. But when it comes to the authorization token, that's where things get a bit more complicated, so try to stay with me. Here, we need an authorization token with the playlist modify public scope. And to get one of those, we need to follow these steps. We first request authorization with the scopes we need. Spotify prompts us to authorize, which we do. That gets us a code, which we then exchange for an access and a refresh token. And we use the access token in our add song request. But the access token is only valid for 1 hour, so when it expires, we need to get a new one with the refresh token. Are you still here? Great. Now we can get to building the requests. And we can do this manually, but I prefer to use Postman because it allows us to structure our requests in a very organized way, and also lets us easily convert our requests to code for later use. Let's take a look at our first request. Here we need a client ID from our Spotify app, which we will shortly create, a response type, a redirect URI, the value for which must be whitelisted in the Spotify's app settings, and our scopes. Now we can hop on to the Spotify developer dashboard and create our app. Afterwards, we copy the app's client ID and client secret for the request we're about to make. We also need to whitelist our redirect URI. For that, I'm going to use the Once Upon a Code website. With all that done, we can now create our code fetching Postman request, which should look something like this. We now copy the URL and paste it in our browser, since the authorization page requires JavaScript, which Postman cannot run. Then click Next, agree to everything, and our code magically appears as a URL parameter. Going back to Postman, our second request, aka the token fetching request, should be similar to this, with our previously fetched code pasted as a parameter. The request also requires an authorization token, which the documentation tells us needs to be the app's client ID, client secret, encoded in base64. Lucky for us, most browsers have a built-in base64 encoder, which we can use in the browser's developer console, like so. Executing the request gives us the long-awaited access and refresh tokens. The access token goes into our add song requests authentication header, followed by the playlist ID and the ID of the song that we want to add. If you're wondering where we got those from, the playlist ID is the funny looking string after the playlist URL path. And the song ID we get from copying the song's link, pasting it somewhere, and just like before, the ID is the funny looking string after the track URL path. Now it's time for the moment of truth. Drumroll please. Wait, what? That actually worked? Cool. I guess the only thing left to do here is to refresh our access token once it expires, which we can do with the following request. It too has the base64 encoded auth header, along with a grant type, and our refresh token. Whew, that's a lot of work done. With this, we're mostly finished with the Spotify requests, so let's just move on to the fun part, making our Discord bot. Our first step is to create an application in the Discord developer portal. Then navigate to the bot tab and click on Add Bot. And while we're here, let's just note down our bot token and client ID for later. Now we can add our bot to the Once Upon a Code Discord server. This is done via a special link that the Discord permissions calculator generates for us. We just specify the permissions we need the bot to have, its client ID, and the calculator spits out our invitation link. Once we open it and naturally click Next, Next, and Finish, our Tune Marshal is finally home. But he's offline and not doing anything. So let's take care of that with the help of Node.js version 12.18.3. We're gonna crack open a terminal, create a folder for our project, navigate into it, and initialize our Node app. The Y argument generates our app without asking us any questions. As a side note, we're gonna use ES6 syntax extensively. That's a tongue twister. So if you need to brush up, you can visit this link for a refresher. With that done, we can create our main.js file under the source directory and add a start dev script in the package.json. Since we will be using many sensitive project-specific variables like API keys, client secrets, and such, it's always a good idea to keep them in a separate environment variable file, which we can exclude from our Git history. For that, we're going to use the .env package, which we install using npm i.env. Afterwards, we can add the -r.env config flag to our start script. That's going to make Node look for a .env file in the root of our project and load its contents into the process.env variable. To test it out, we can create our own env file in the root directory, add a test variable, then try to load that variable inside the main.js script, like so. And it works. Moving on to our Tune Marshal. We can use barebones HTTP to talk to the Discord API and control what our bot does, but more times than not that gets a bit too cumbersome. A good alternative to this is to use an API wrapper, and since we're using Node.js, we can take advantage of Discord.js, a library which, by its own words, is a powerful Node.js module that makes your bot code tidier and easier to understand. Installing it is as easy as typing npm I discord.js, and getting started with it is a matter of pasting the included quick start snippet in our main.js, replacing the placeholder token with our own Discord bot token, and since we added that token to our .env file, like so, we can use it by calling process.env.discordBotToken. Taking a closer look at our code, we require a Discord object from which we instantiate a client, which we use to register to event listeners, and then log in the client with our token. The first event triggers whenever the client logs in, and the second event triggers whenever any message is sent to any channel belonging to the server in which the bot resides. For our purposes, this can either be a private channel, DM channel, or guild text channel. As a side note, we also updated the variable declarations to use ES6 object destructuring, for purely aesthetic reasons. If we now run our startup script, we can see that the tune marshal goes online, and if we type in ping in our channel, he responds to our message with a pong. That's fantastic! I have the Discord app installed on my phone, and when the marshal replied to my message, I got a little notification. And I will receive a notification not only when someone replies to my message, but when any message is sent. This isn't that much of a problem when there's only me and the marshal in the guild, but that could easily turn into this if enough people join the server. Let's remedy this by going into the server settings, scrolling to the default notification settings, and changing them to send notifications only when someone mentions you. That takes care of that. Now going back to our project, let's try and overview the commands that our bot needs to respond to. We will definitely need an add song command, another one that will send the users a link to the playlist, and one default command that shows the users all available commands if they enter something else. The commands will be structured accordingly. Every command will start with an exclamation mark, followed by the command itself, and the add command will also require a song URL parameter. We can now go back to the project, clean up the code a bit, and start processing our messages in the message event handler. As we discussed, our command prefix is going to be an exclamation mark, so if the message doesn't start with that, or the message author is a bot, we just stop executing right there. But if it does start with the prefix, we can parse our arguments in the command name. Then we will make a switch statement for our commands and the methods that will take care of said commands. It's a good idea to separate the logic for every command in a separate file, that way our main.js doesn't get cluttered up. We need a commands folder for our add.js, playlist.js, and default.js. Initially, their contents will be basically the same, a single function logging its name and the export of said function, except for default.js. There we will name the export function default command since the default keyword is reserved in JavaScript. We can now import these functions in our main.js and test them out by running our app. Over to Discord, add triggers add, playlist triggers playlist, and anything else triggers default. Everything is as it should be. With that done, we can move over to building our commands functionality, and since I feel like it, we're going to start with the default command. As discussed, it will need to display a list of available commands, so let's just make a commands array and pass it to the default command method, along with the original message. Then we update the default command method signature and deconstruct the original message to get its author and the channel it was sent in. We need the channel because of its type property, which describes the type of a channel the message was sent in. For our uses, that could either be a DM or a text channel. And if the message hasn't been sent to the bot in a DM channel, we await its deletion to clean up the message channels. This will also apply to the other commands. So, after the DM check, we use the send method on the author object to send them a private message with the available commands. We do this in a private message as to avoid gunking up the channels with unnecessary messages. You might have also noticed that we surround and join our commands array with double asterisks. That's because we want to emphasize the commands by bolding them, and that's the way we tell Discord to bold our text. Think of it as a sort of markdown syntax. Moving on to our playlist method. Again, we pass it the message variable and update the method signature of the playlist.js. We also add the Democratic Bangers playlist link as a variable in the .env file. Then import it. And just like before, we delete the message if it didn't go down in the DMs, and send our author a private message with the playlist link. And finally, we move on to the addSong method. Here the parameters we need are the client, the original message, and command arguments. So we add them to the method invocation as well as the method definition. Then we deconstruct our channel and author variables, as well as the first argument, which for now we hope is the song URL. Then again, we delete the message if it's not sent in the DMs. Now we're going to make a Spotify.js helper file that will contain all of our Spotify related logic. In it, we define and export the Spotify class. The class will contain an access token variable with a placeholder value, and for the constructor parameters, we require a client ID, client secret, and refresh token, which we set to their corresponding class fields. We also need a refresh access token method to refresh our token when it expires, a getTrackDataFromURL method to check if the provided argument is actually a Spotify song URL, and if that's the case, to provide us with some track metadata, a fetchTrackData method, and last but not least, the addTrackToPlaylist method. And here is where all the hard work we did in Postman pays off. If we hop back to the refresh access token request in Postman and click on the code button, what do you know? Our request is coded up and ready for use. Since we've chosen for Postman to generate an Axios Node.js code snippet, we also have to install the Axios and QS dependencies for the snippet to work. That we can do by running npm i axios qs. Afterwards, we copy the Axios and QS definitions over to our Spotify.js, and the rest of the snippet we copy over to the refresh access token. If we clean it up a bit by consting our vars, pasting our refresh token to the request data, removing the Postman cookie, adding our base64 encoded basic auth token, returning the access token in the request response, and catching and logging any errors, we have ourselves a working token refresher. Next up is the getTrackDataFromURL. Here we instantiate the URL object with our URL string parameter. That parses the URL for us so we can get the host and path name. Then we split our path name into a track path and track ID. Afterwards, we check to see if the host and track path are what we expect them to be. If that's the case, great. We fetch and return the awaited track data. But if it's not, we throw an error, which we will later catch, so don't worry about that. On to the fetch track data request. You might be thinking to yourself, wait a minute, we didn't make a get track data request. And if you are, that qualifies you for a free Lamborghini. Either way, we need to make one, so let's quickly scrap something together. Let's see here. We have our documentation, the request URL, and the request is done. And we can copy its code snippet over to our project. In goes our request config containing the track ID and access token. Then we return our Axios request after having mapped its response to be an object containing the track URI, track name, and an array of the featuring artists. Here comes the interesting part, the catch block. If we call any Spotify API URL with, for example, an expired or invalid token, we will receive a 401 expired token response. So we need to check for such a response, and in that case, we need to refresh our access token and recursively call fetch track data. When using recursion, it's always a good idea to identify the function's exit statements as to avoid headaches. In this case, the recursion stops whenever the fetch response goes through without an error, or whenever the caught error doesn't have a status of 401. Here you might have noticed that since we use a placeholder value for the initial access token, fetching the track data will always fail on its first try after the app starts. And then it will fetch a valid access token by itself. So we don't need to provide any meaningful value for the internal access token, which is exactly the idea here. Moving on to add track to playlist. We repeat what we did for the fetch track data method and paste our request config, making sure to pass the track and playlist parameters into the URL, as well as the access token in the header. We return the configured request, this time logging if the request goes through. And again, if our token is invalid or expired, we recursively call the function again after fetching a refresh token, and log anything else. This basically concludes our work on the Spotify class, so we can go ahead and use it. But first, we need to add several variables to our .env file for our Spotify class to use, namely the Spotify client ID, client secret, refresh token, and playlist ID. Then we can go on and import them and the Spotify.js file we just made into add.js. Then we can instantiate a Spotify object by calling new Spotify and passing it the client ID, client secret, and refresh token. With that, our Spotify helper is ready for business. So let's put him to work by fetching the track data of the provided URL argument. Here we get the track data by awaiting the getTrackData from URL called with the provided URL argument. And it has to be surrounded by a try-catch in order to handle the cases where the provided link is not correct. In which case, the tune marshal DMs the author, explaining them what might have went wrong, and because we return, the code execution stops there. But if the catch statement doesn't trigger and everything goes accordingly, we can get our song URL, song name, and artists from the response we mapped. By this point, we have everything we need in order to hold a vote. The only thing that's missing is the vote format itself. So go along with me and just close your eyes for a moment. All done? Okay, hear me out. Now imagine the Discord channel is actually a Twitch stream. And how do we let someone know we like or dislike something on Twitch? That's right, PogChamps and Weird Champs. But because this is Discord and not Twitch, we won't spam them in the chat, rather we will use them in the fantastic Discord feature, Message Reactions. That's right, our bot will start the vote by sending a message to the Spotify Song Vote channel, then it will wait for a minute and count the number of reactions the message got. If the Pogs are more, then great, we add the song to the playlist. But if the Weird Champ count is greater, then we do nothing. And if it's a draw, well, we'll figure that out later. But for now, we can move on. We begin by creating the Spotify Song Vote channel and noting down its ID as well as the guild ID. Then we head over to the server settings, adding a PogChamp and Weird Champ emoji to our guild server emojis. We also have to note down their identifiers in order to later count them. Since we know we're going to be using the await reactions method to listen in on the vote message's reactions, we know that it returns a promise-wrapped string message reaction collection. That message reaction can either be a reaction emoji or guild emoji, and in either case, we will use its identifier property. I've already went ahead and noted these down for our custom emojis, so we can now paste everything in the .env file. The Once Upon a Code guild ID, the Song Vote channel ID, the PogChamp emoji ID, and the Weird Champ emoji ID. Everything is taking form now. After we import the new environmental variables and get our vote channel object, we can use it to send the vote message. In it, we specify the song's name and featuring artists. We notify the users of the time they have to vote and the emojis they can use. We'll also mention the guild member that proposed the song addition and the song's URL, which will later give us a nice track preview. Lastly, we'll include the @here string, which will tag and send notifications to all the online guild members that the vote message has been sent. I might have to remove this later if the notifications get a bit too spammy. With our vote message sent, it's time to use the await reactions method. As you can see, it requires a filter object and supports several configuration options. Taking a look at the example clears things up a bit. The filter basically accepts or rejects reactions based on a predicate that we defined. In our case, it will filter out all emoji reactions which aren't either PogChamps or Weird Champs. And the options are there to manage when the reaction collection stops. Again, for our use case, we will use the time and maxUsers options, stopping the vote if either 1 minute has passed or if all the online users have voted. Getting the number of online guild members is easy. We first fetch our guild object by its ID, then call fetch on its members property. That gives us a list of all guild members, which we can then filter to only contain members which are online and not bots. Now for the reaction filter. Here we can take down 2 birds with 1 stone. If we assign our emojis a value in a map, for instance, a vote for has a value of 1 and a vote against has a value of -1, we can use the map's has method to filter out all non-voting emojis. And later, use the emoji's value in the counting process by adding up all their values and checking to see whether the result is positive or negative. A positive result indicating more votes for, and a negative one indicating more against. That's a great idea. Calling await reactions on our vote message with the React filter, maxUsers, and time parameters returns our promise-wrapped reaction map. Each map entry containing all the votes with the specific emoji. Before counting all the votes, we should check to see if anyone has voted at all, and if no one has, we just send an informative message and call it a day. But if there are votes, we can go ahead and tally them up. To do that, we call the reduce method on our reaction map. We multiply the number of reactions using that emoji times the value it has in our map, which is either a 1 or a -1, and then add that to the tally. After this, we should end up with either a positive, negative, or a neutral value, which we will handle in a moment. But first, for transparency reasons, let's make the votes public by sending their counts in a message to the songvote channel. Going back to the tally, as we discussed, we can have 3 possible outcomes. If the Weird Champs are more, we don't add the song and notify the vote initiator. If the PogChamps are greater, we then call the add track to playlist Spotify method with the track's URI and the Democratic Bangers playlist ID. Then we notify the vote initiator of their exquisite taste for the finer things in life. All that's left to cover is the draw case. Well, there's only one thing to do when democracy fails us. That's to have a coin toss. We pause the code execution for dramatic effect. Do the JavaScript equivalent of a coin toss. If it's heads, we add the song. If it's tails, we don't. All that's left now is to test it out. Say some wise guy moseys on and tries to pull a fast one. The villagers immediately spring into action and stop that from happening. Then comes another guy and offers up a masterpiece. Naturally, the villagers collectively vote in favor of it being added, which immediately manifests after the vote ends. And now our Good Samaritan wants to check out the playlist, so he types up the playlist command and boom, it's right there before his eyes. Oh yeah, and the coin flip works too. Don't believe me? Well, you can actually try it out yourself in the Once Upon a Code Discord server. The link is in the description. Join now, so we can help the villagers make the greatest democratic playlist the world has ever known. If you like this story and want to see more like it, consider subscribing and enabling notifications. Thank you for sticking till the end, and I will see you in our next tale.